Okay, in this section we're going to talk about the point-slope form of a line. And this formula is helpful in finding the equation of a line in two situations. For one, if you know a point on the line and the slope of the line, so in this case the point may not be the y-intercept, it could be any point on the line and the slope of the line. So if you know a point on the line and the slope of the line, you can use this formula to find the equation of the line. And then the other situation where you can use this formula is if you know 2 points on the line. Because if you do know 2 points on the line, you can always find the slope from those 2 points. So the formula for this point-slope formula is y minus y1 equals slope times x minus x1. Now y and x are the variables that will be in the equation, but the y1 and the x1, those are the values of the point that you choose that's actually on the line. So, and I say the point you choose because in case it's in the second case where you're given 2 points, you could choose either one. But let's take a look at a couple of examples here of how we could use this formula to find the equation of a line. So right here it says the line containing the point. Well, we want to find the equation of the line that contains the point -2, 5 and has a slope of -2/3. And also we want to write the equation in slope-intercept form. Okay, so since I'm given a point on the line and I know the slope of the line, then I can use the point-slope formula. So I'll take this formula y minus y1. Well, what's the y value? The y value is 5. So it'd be y minus 5 is equal to the slope. So the slope would be, in this case, the slope is -2/3. So the slope would be -2/3. And then times the quantity x minus the x value. And the x value is -2. So you would have y minus 5 equals -2/3 times the quantity x minus -2. Now I know that's actually going to be x plus 2, and you could skip that step there if you wanted to and just go on to this step. But let me go ahead and do that here. So x minus -2 is simply x plus 2. Now what you need to do here is go ahead and distribute the -2/3 x through x and -2/3 times 2. So -2/3 times x would be -2/3 x, and then -2/3 times 2 is -4/3. And then the last step, you need to add 5 to both sides so that you can get the y by itself. So if you add 5 to both sides, you would get -2/3 x minus 4/3 plus 5. Now I know that -4/3 plus 5 is actually 11/3, but in case you're not sure how I got that, what I did is I got a common denominator and I wrote 5 as 15/3. And that way I can actually combine -4/3 plus 5/3, plus 15/3, and -4/3 plus 15/3 is 11/3. So in slope-intercept form, the equation of my line is y equal -2/3 x plus 11/3. Now, if you're asked to find the equation of a line that contains 2 points, then what you want to do there, you can still use this formula, but before you use it, you're going to have to find the slope of the line first. And since we're given 2 points, we can do that using the slope formula. So to find the slope of the line, you just take the second y value 8 minus the first y value 4, and you get 8 minus 4. And then you take the second x value, which is -5, and subtract the first x value, which is -3. And so I did that in my head because I know that if I take -5 minus -3, well, -5 minus a negative would be -5 plus. So -5 minus -3 is -5 plus 3. So therefore the numerator 8 minus 4 is 4, and then the denominator -5 plus 3 is -2. So 4 over -2 would be the slope, and 4 divided by -2 is -2. Now, we can use either point, and I'm going to use this. I really wish that I had scrolled that down so you could see, but I'm going to use the point negative 3, 4. So I could use the point negative 3, 4 or the point negative 5, 8. So I'm going to use the point negative 3, 4. And remember, I'm using this formula up here, y minus y1 equals the slope times x minus x1. Well, I know the x1 is negative 3, and I know y1 is 4, and I know the slope is negative 2. So plug those three values in, and I get y minus the y value, so y minus 4 equal the slope negative 2 times x minus the x value. Now the x value is negative, so when you do x minus a negative, you get x plus. So x minus negative 3 would be x plus 3. And then you can distribute the negative 2 through. So take negative 2 times x, and you get negative 2x. And negative 2 times 3 gives me negative 6. And then if I add 4 to both sides, that'll give me the y by itself. And so I'll get negative 2x minus 6 plus 4. And then I can combine minus 6 plus 4, and I'll get minus 2. So the equation of the line would be y equal minus 2x minus 2. Now, this line, I kind of threw this in there kind of to trick you a little bit, but you could actually use the point slope formula to find the equation of the line that goes through this point and has a slope of negative 3, but you don't really need it, because if I'm giving you this point, well, since x is 0, you know that this is the y-intercept. So actually, if you think back to the slope-intercept form, we know that b is negative 5, and we know the slope is negative 3, so we know m is negative 3. And so if you think back to y equals mx plus b, then you can just write this as y equals negative 3x plus negative 5. And again, that's using the slope-intercept form of the line. Again, we know the slope is negative 3, we know the y-intercept is negative 5, therefore we don't really need to use the point-slope form. We can use the slope-intercept form to get that equation. Okay, I've got one more here I'll do. I've got this one, the line containing these 2 points. Well, what's interesting is if you find the slope of the line that goes through these 2 points, you'll get 3 minus 3, which is 0, over 5 minus negative 1, so that's 5 plus 1, which is 6. So you can show easily that the slope here is actually 0 divided by 6, and 0 divided by 6 is 0. So the slope here would be 0. Now I'm going to use the point negative 1, 3 and use this formula again that we had up here. So since I'm using 3 for the y value, then I'd have y minus 3 over here. And since I'm using negative 1 for the x value, this would actually be x minus negative 1, and x minus negative 1 will be x plus 1. But since I know the slope is 0, all of this is going to disappear anyway, because if I multiply 0 times all this, it's just going to give me 0. So what I end up with is y minus 3 equals 0, and then move the minus 3 over, and you get y equals 3 for the equation of that line. Okay, I'm going to wrap up this section with a couple of statements here. Horizontal lines will always have the equation y equal k, where k is a constant, and vertical lines will always have the equation x equal k, where k is a constant. So if you were given the line x equal 3, if you wanted to graph that, all you would do is graph the vertical line that goes through the point 3, 0. So it would just be a vertical line that goes through the point 3, 0. So, you know, it would look like that. Okay. And then if you wanted to graph y equals negative 2, it would be the horizontal line that goes through the point 0, negative 2. So it would go through the point 0, negative 2, but it would look like that. Okay, and then what's interesting is the line x equals 0. Well, that's a vertical line that goes through the origin. Well, then that would simply be the y-axis. So if you think about it, let's draw a quick grid here. Cartesian coordinate system. So let's say that's the x and the y-axis. Well, it turns out that the equation for the x-axis is the line y equals 0, even though it's the x-axis, and the equation for the y-axis is the line x equals 0. Okay? Alright, so the next section I'll talk to you about perpendicular and parallel lines.